Hey guys, Professor Doney back. I thought I was done with conservation of energy, but I want to do one more conservation energy problem for you that involves something a little different. In this one, we're going to have some loss of energy. Our problem is going to be we're dropping this object 1 kilogram from initial velocity 0, so it's a drop problem. We're going to drop it from a height of 10 meters until it hits the ground. We're going to call this point A. We'll call right before it hits the ground point B. And we're saying there's a loss of energy. Now that loss of energy can be due to a number of things, but one of the big culprits of energy loss is the force of friction. Okay? When friction acts over a distance, we call that work. Work is force through distance, and this is the work done by friction. Since friction is always opposite direction of motion, it's negative work, which is basically telling us, hey, we're pulling some energy, losing some energy. So friction reduces the energy, overall energy we have as it goes along, which is important in roller coasters and anything moving or sliding. So we're just going to involve a problem like this. And what we're going to do is say, well, let's find a couple things first, then we'll talk about the loss. Find part A, total energy. Now total energy, according to conservation of energy, is the same at point A, point B, and anywhere in between. But what we're going to do is start out and say the total energy is equal to the energy we have at the top, which is A. And looking at that, we only have potential due to gravity. Now you have to look at the previous videos if you're not understanding why I came up with that, because there's no spring energy and it's not moving, according to that, so there's no kinetic. So all the energy at the top is going to equal mass times gravity times height, which is 1 times 9.8 times height, which is 10. That gives us 98 joules of energy to start the problem. Now conservation of energy says we can't get any more, we can't add to that unless we change the problem. So that's how much I have. That's how much I would have at any point along here. It could just be into different types, whether it's potential and kinetic, blah blah blah. Now looking at this losing energy, I'll make it sort of a reddish here. Losing energy means that we start with 98, but when we get somewhere else we have less. So let's say here by point B we've lost half of the energy. So half the energy you had at A, we lose half of it. What does that say about the energy at B? It says that the energy at B is going to equal half the energy at A, which is going to equal half of 98, which is 49 joules. Now that's 50% loss. I don't know if that's good or bad. Certainly usually not good, but it could be a lot of air resistance between the object, parachute, things like that. Alright, but what does that mean? That means when we look at that problem now, we look at the energy at B, it equals 49 joules. Now, what kind of energy do we have at B? If we're saying it's right before it hits the ground, it's pretty much all kinetic, maybe a smidge of gravitational if it has a slight height to this, but we're saying it's paper thin before it hits. We're going to say it's all kinetic. So we're going to set that 49 equal to 1/2 mv squared. That's going to be half times 1 velocity at B squared equals 49. If we go through that, velocity at B is going to equal square root of 98, pretty much 10 meters per second. Okay. Now that's because we had the energy loss. If we drop from that height, if we drop from that height and do not lose energy, we would have set it equal to 98 joules because that's how much we had originally. If we go through that and use 98 equal to the energy at B, we'll come up with a velocity at B, I think somewhere around square root of, 196 square root, somewhere about 14 meters per second. So we can see that the loss of energy does have an effect on our results. It's air resistance on our car, which is why they make them aerodynamic. It would be, we get much better gas mileage if they are more aerodynamic. Airplanes, drag, stuff like that, friction. So we see there a problem where we have loss of energy involved. Hopefully it helps. I think we have one more energy one related. It's going to talk about watts and power and horsepower.